Okay, so we can also find a gradient when we are looking at a graph just by looking at the rise and the run. Now, when we talk about rise and run, we're essentially going to count how many we go up, and then we divide it by how many we go across. Or if it's a negative gradient, it would be how many we go down and how many we go across. And again, it doesn't matter what 2 points on a graph you pick, as long as you are clear on what you're doing. So for the graph we've got on the left, I'm going to start at the x-intercept just because it makes life a little bit easier, and I'm going to count up and I'm going to go to the y-intercept just because it's an easy marking place. So I go, okay, I'm going up 3, and across 3. So my run is 3, my rise is 3. So my gradient is m equals 3 divided by 3, which gives me a gradient of 1. Now, if I was to have a slightly different graph, and again, I'm just going to do this as a sketch, all we have to do is count how many points we go up. So if we say that this is 3, and we'll go to a point here that's 4 and 5, we would say, okay, how many do we go up? We go up 2, because the difference between 3 and 5 is 2. We go across 4, which gives us a rise of 2, a run of 4, which gives us a gradient of 0.5. Likewise, if we're doing it as a negative gradient, it would just mean that the line is going down. And again, you just pick 2 points on the line, and it doesn't matter what 2 points, and count your grid. So if I say that this one is 1, and down here we'll have 4, we've gone down 3, which means our rise is equal to -3, and we've gone across 4, it's our run. So our gradient for the blue line would be -3, which is our rise, or in this instance our negative rise, over our run, which is 4, which gives us a value of -0.75. Now you can leave it as a fraction, and it will help you sketch your graphs from it, but equally a decimal is correct.